So now let's start preparing the geometry so we can build our skeleton faster and with more precision. But before that, there's a necessary and very important step that I used to tell, like sometimes even daily for my team, sometimes weekly, in a weekly basis. That is, you always have to check the geometry or whatever you are introducing into your setup in your hip. Uh, Working in Houdini, especially, you see that kind of idea, especially for artists working with at least more than 10 years in Houdini. It's like cooking. When you learn how to do professional cooking, or not just the cooking for simple meals, but more complex dishes, usually the process is to prepare all your ingredients, check everything, make everything ready, cut it, slice it, whatever, and then you start cooking. So it takes a lot of time, and usually the ingredients, they will limit or raise your meal, whatever you are cooking. So if you have bad ingredients, your dish will be as good as the ingredients you have. This is the same idea. So take the time to inspecting and checking, and if needed, adjusting the geometry or whatever you are introducing in your hip file. We have several problems in a lot of projects because the geometry hasn't been validated. Things like diamonds without the correct beveling, and introducing some incorrect refractions, and a lot of things that could have been avoided if the geometry or the assets were checked, were validated more carefully. This is the same thing. And let me show you what I did. This is the piston that I bought, that was provided. And this is the one that I adjusted. There is this small difference, but the interior here was a little offsetted. Let me see if I can show you. Yeah, this part here, it was a bit offsetted from the center. So when the piston moved, you see this. It was not a jiggle, but you see this difference of movements. And well, I didn't check the geometry because I thought it was correct. But again, this is something that we all have to do before working. Since this was just a test for me, I was a little bit lazy. But when I am working on an actual project, I'm not this lazy. I check. I take my time analyzing the assets before I start working on them, and this is the same thing. Another thing here, usually I try to avoid changing the topology of the geometry that someone provided me. Usually, if this was an actual project, I would send this back to the modeler, and I would ask him to correct the problem in geometry. Sometimes, even if you ask the modeler, when you need precise positioning, sometimes they can't, or they don't know how to do that, and in the end we will have to do those things by ourselves in Houdini. Hopefully we won't need those kinds of works or projects, but or tasks actually, but sometimes that happens. And again, I avoid change the topology. If this was an actual project, I would try my best to just change everything, just reposition everything, but keeping the point numbers and everything else the same. Since I wanted to do this quickly, I changed the topology. So what I did here, this just to give you an idea of what I did. I split this and I use these inner parts to reposition. Well, you can see, this is, well, very badly positioned. See, it's not centered. So I used this part that was my guide to center the other one, and then the other one, and then this as well. I'm not sure what I did here. It's just a small position. And one thing that for me it is very important at this stage, especially for this kind of rigs that we need exact joint position. I already I did some groups that I use as the geometry to put the joint exact in the center of this group. So as you can see, this I create this group called piston top B centroid. I'm very bad at naming, so hopefully you do that in a better manner. But I called piston A and B to understand which one is which. So this is where I will add the joint for the top part, and this is where I will add the joint for the bottom part. It's important to be very careful, because since I'll use geometry as a guide for the bounding to place the joint, this is not full symmetrical in all the axes. As you can see, it has this hole here. So I had to do this grouping by hand. For this, this is something that I see that not everyone is aware of, but Houdin has this visibility operator here. So what you can do is like select this using connectivity, and then you can select your geometry. Actually, yeah, I was wrong. For this part, we can use just the connectivity for selection, but if I'm not mistaken, some part here I had to select by hand. So this is the piston with the correct positioning. This was just simple vex to put that again in the right position. So yeah, as you can see, I use the centroid to move this piston from here to here. Simple stuff. So now we have the correct piston, actually the correct pistons with all the groups. So those two groups where we will add those joints. Here I correct the naming for the groups, since I was just duplicating the geometry. Here I correct the naming. So let me show you. We have this 4 groups, actually. There are more. We have this 8 groups. And this piston a base is this here, this joint here. So this is easy, is this joint, but using the Y, sorry, this is not the Y, this is the, let me see, which one is this group? So not sure where I created those groups here. Oh, I'm sorry. These are the groups for just the capturing, and this with the centroid postfix is the one that I'll be using for the joint placement. So the other the placement of the other joints, it's they are easier. So you do that later on in the next step, the next video. So this so long. So here we have the geometry. I will provide this geometry here. I just remeshed it just so the geometry is not the same as the one that I bought. So this is what we'll get. Here I deleted the groups with the centroids, the ones that I'll be using for the joint placement, and I kept just the groups for the capturing. So as you can see, we have 5 groups because we will have 2 parts for each piston plus the base. And here I'm just converting these groups into naming, and here is just a remesh, simple stuff. And here I will pack using the naming. And in the next video, we'll create the base skeleton, but here we have a few more joints, but we'll have 5 joints. This, and let me see, top. Yeah, these 5 joints with the same naming as this package geometries. So when we capture just using the name attribute, as you can see here, all of them were captured. You can see that all of them have this weight of 1, so just one joint influencing the movement of that part. But we'll take another look at that in the next video, and hopefully I'll see you in a bit.